Until YouTube tells me, you've got too many videos, you got to delete something. I don't know if they have a limit or not. Well, good morning. I did finally, got through the week 4 hand-in homework part 2 this morning. I'll get through the week 5 that you just turned in. I'll get through that this afternoon so that you get some feedback on that one also. If something though related to that is on your mind, you know, bring it up, ask the question today. Anyway, so kind of starting backwards like we did last review here, last chapter, but so here's one of those favorites for everybody.
So just confirming the test is tomorrow, right?
Test tomorrow, no class tomorrow, right? Just find your hour to get it done. You know, 10:59, you start, middle of night. Nobody does that.
I know. And do you know how many questions it is?
Yeah.
How many questions is it?
Smart Alec. I actually went and reviewed it. It's 10 questions.
Okay.
Only 10.
Okay.
6 minutes apiece, huh?
Thank you.
Mm-hmm. I took one out. It's easier to make it, 10 questions into 100 points too. Yeah. It doesn't really matter much, but I was thinking about the time. There, I figure these all take a little bit longer than like last chapter. So try to not overdo it for you. Okay, well, let's see. And there's somebody else just joining. All right, so the idea here is kind of like one of those last ones in the 3.4 homework. This was supposed to be that riverfront type problem, right? And here's where I described you kind of have to make up your own formula. If you think of this as a length and this is a width, that's what I was implying here with my words. You've got one length plus 4 widths to equal that total amount, all right? And
so where are you getting 4 widths from?
pardon?
Where are you getting that 4 from?
1, 2, 3, 4 pieces of fencing that are all the same length, width. Yeah, that's the...
See, I would never have gotten that. I would have gone, there's only 3 pieces there.
See, so we're talking about the fencing, right? All the lines, add all the lines together, not including the water, apparently. Or, I was going to do one of these, next. Similarly, right? 1, 2, 3 widths, but 2 lengths in that shape. All right? So here I'd be 2 lengths plus 3 widths. But now we still need some sort of relationship between them. The length is 5 more than 6 times the width. 5 more than 6 times the width plus 5. So there's our way to use W instead of L. This expression, really just the way I've written it, is going to go right there instead of the L. This is exactly what we're going to do part of in chapter 5. These are called substitution problems. There's actually 2 different conditions because we have 2 different variables. We need a second condition that describes one in terms of the other so we can get rid of one of them. But, so we're sort of like practicing ahead of time. But we get to make equations out of this. So that's the idea. All right, so I'm going to do that substitution right here. Here it goes. I'm going to move it over just a little bit. Here it is. 6W plus 5 is the L plus 4W equals the 125 total. Some of us still have issues with the idea of like terms. This is 6 W's and 4 more W's means I have 10 W's. I think I saw somebody do something like, it was part of a hand-in homework problem, and they said, oh, 6 minus 2 W's means 4 W's. That's just a number. 6, always a 6. This is 2 of whatever. You can't put those together. Right? And now that should be kind of easy, I hope. Now that I finally fixed my problem, let's subtract the 5. So 10 W's is 120, right? Dividing by 10, I get that W is 12 feet, right? Divide by 10.
Okay, this makes so much more sense because when I was doing the problem on that, I was doing it by the 3 and I could not get the answer proper. So
Oh,
that would make sense. So we really need to think of the fence not as just these cubes. We need to look at the actual lines dividing the wooden block.
that's it. Yeah, you're pointing out. The problem was probably described as dividing it into 3 sections. I get it. 3 sections, sure. I got my horses here and my sheep here and my cattle here, right? 3 sections. But that means I need 4 pieces of fence. Yeah.
Okay, because I didn't even think of the fence. Exactly, that's what the word problem is asking us to find, not the little canals themselves. I literally didn't get this when you did it yesterday, and I didn't get it when I did the homework last night, and I'm so glad you went over it today.
Ta-da!
That was the piece of the puzzle I was missing to do this correct.
Okay, now that you got it, I'll take it off the test. No, I'm just kidding. I'm not even saying it's on the test. That was a bad joke. Go, kitty. Go, kitty mouse. All right, so, and notice it said length and width. So if the width was 12, right? Why am I thinking I'm dividing wrong? No, divide by 10. I got 12 feet. And so the length is going to be 6 times that. That's 72 plus 5. Why am I? 10 W's. Subtract the 5,
77.
20 is 12, right? W is 12. Length is 6 times that is 72, right? Plus 5, 77. Oh, because it's 4 W's. Okay, 4 times 12. I'm going to say 72 plus 12 doesn't equal 125. 77 plus 4 times 12 will equal to 125. And don't forget feet. I was confusing myself there. Hope I didn't lose you. Okay. Is that, I'm sorry, who is that talking to me? Is it Krista that's saying you got it this time? Or, I mean, I'm sorry.
It was Kayla.
Kayla, okay. I had a Kayla, a Christy, a Krista. Yeah, anyway, thank you. Okay.
You have a lot of K's in this class.
Pardon?
You have a lot of K's in this class.
Yeah, oh well. Popular at some point, right? I did this one. Let's see. Do you want another one of those, or do you feel like it clicks now? Should we do
If
one?
you have another one, I'll take it.
Do it?
Do another one.
Okay. Let's see, because I'm using this picture. Hopefully that's good enough right now. A little messy, but let's say 90 feet total. And what was my problem? Length is 4 feet less than twice the width. Squeeze it in. Getting messy out there. Just make sure that's what my problem is here. So this kind of, again, I kind of say, kind of make up your own little formula, counting how many pieces, right? So I'll call it total or perimeter. I called it perimeter because it's kind of related to those rectangle problems. Called it perimeter in lesson yesterday, I think. How many, right, lengths and how many widths? I think I'll wait for you, okay? How about I'll just be quiet for a minute. But if you're stuck, let me know. I think you should be that far along already, at least. And then you got to come up with some way to say length using the W. This one needs parentheses. Right, this whole thing here is going to go in there. Two of those, two of those. Some like terms again. Get the W alone. Pull out that calculator if you want. Does it work for you? Yay! Thank you. See you.
What I'm confused about is where did you get the P to the P equals 2L plus 3W? Where did that come from?
Where did I get this?
Yeah.
Yeah, okay, so I chose P for the perimeter idea, or I could have used T for total, but the total length, right? That's the P stands for the 90. The 2L, here's where I'm looking at my drawing, right? I'm talking about how many pieces of fencing.
Okay.
So I have two of this long side of fencing. And I have three of the short width of fencing. So two of the lengths plus three of the widths. That's how you got to look at those drawings.
Okay.
That makes sense that way?
Yes. Thank you.
Okay. So that's where that comes from. So that's my, build your own formula idea when I say that. Then this one, we've been doing this kind of thing for a while now. Interpret, translate that part of the problem into this expression here. That's supposed to look like a 4. I cleaned up. Because we can't really solve one equation with two letters in it and get us two variables and get a single number we would always have one of the letters left in it. That's what you've been doing in some of your homework, right? Solve for this letter. Okay, is that good enough? We'll keep moving here, all right? All right.
So I actually have a quick question. I'm looking at the last one we did and the one we did before that. So the way you got the two lengths for the last one was because there was two blocks, right?
I was just thinking of it as, if that's a rectangle, how many lengths are in that rectangle? How many long sides?
One.
There's a long, see, there's two of those, right?
So is the reason why we went with two lengths in the last one versus the first one because of the fact that they gave us the length in the word problem versus them not giving us the length in the second and the one we did before that?
So here's your basic rectangle, right? Simple rectangle. There's two long sides and two short sides. Perimeter is two long sides plus two short sides. Add up all four sides. Here's the one I made up with the water a minute ago, the comb I could call it, right? There's only one long side and four short sides.
So I guess I need to word my question differently. So in the fencing problem, we were given in the word problem, the length was 5 more than 6 times the width. Versus the very last problem, we weren't given specifics on what the length was, which was why we had to use 2 lengths versus what the word problem told us was the length.
I think the one we just did, this one I said it was something 4 less than twice the width.
4 less, yeah.
4 less than, the length equals 4 less than twice the width. I told you what the length was this way, right?
Kayla, I think where you're getting confused is the first one was on a river and didn't need a length of fence on both sides, only the length on one side.
Okay, thank you. Thank you, that clarifies.
That's why I kind of tried to draw it this way without the river. I was double checking that. Was that it? Does that make sense?
That helps a lot, trying to figure out the differences between the two problems. Yes, that does help.
I'll put, waves, white cap. Yes, okay, yes. I'll make sure it doesn't look tricky if it's on the test, okay? Yeah. All right, good. Good questions, thank you. All right, let's see. Let's do a couple triangles and all right. This one I purposely turned over. Pythagorean theorem problems. You know the Pythagorean theorem? Can you write it down for yourself? The squares and more squares.
I have a quick question.
Yeah.
After we work through these ones, can we work on some percent problems?
I think that, yeah, I'm kind of working backwards through our chapter, and that's what's next on my sheet. Yes.
Perfect, thank you.
Like, kind of thinking, okay, the last things are always the hardest. So if I work backwards, maybe that's a good approach. That's kind of what I was thinking there. There's the theorem. I forget if it's given to you or not. You need to know that, okay? Plan to know that. And then you need to know that this one over here alone is the hypotenuse. And what the hypotenuse is, what it means. And these two are the legs over here. So I got 2 different problems. Remember, the hypotenuse is always the diagonal, the one across from the right angle. So even though it's upside down, this is the hypotenuse here. because it makes a big difference where you put it up there. This one, you're looking for the hypotenuse, the C value. This one, you're looking for one of the legs, and it doesn't matter which one you call it, A or B. So now you got to put the numbers into the formula that you know, and then you solve it. In your very last step, you'll have to square root something. Maybe it's a nice number, you know, and maybe it's not. And I'm pretty sure I will be sure, but if it doesn't work out to be a whole number, it'll give you instructions for how to round it. Remember, we practiced the rounding yesterday. Some of you may be real sharp and say, oh, I know that one just by looking, but you need to show me your work. Like, what does he mean? What's he talking about? I'm going to at least set up. It doesn't matter. Okay. And really, you could subtract 8 squared before or after you square it. That doesn't matter. I kind of like squaring it. That way you avoid any confusion with squaring them alone or together. Right. Gotta get those x's alone, even though they're x squares. If it wasn't just plain x squared, if there were any more x's, we just couldn't do this problem. That's a different class level problem. But we can just square root it because it's plain old x. So that's good. Don't confuse it, Steve. You get there? Does that make x? Square rooting both sides gets me x equals, what number do I square to get 36? Don't try to square it. We want it, it's always smaller, right?
6.
6 is what I would square. So this is a 6. This is just a tricky, not so tricky version of a 3, 4, 5. We're in a similar triangle. If you remember any geometry, these are all just double the size. Remember I said yesterday that was like the simplest, the most basic one. So twice, twice, twice. That's why I said maybe you can do that one in your head, but show me your work. Don't worry about it. Show me your work. Same thing over here. Okay, now this one's turned over, so these two are the legs. Gonna need, really, are those the numbers in my problem? 36, huh? Make sure I'm looking at the right, yeah, okay. I don't know. Definitely calculator work here, right? This is what you want for that one, at least to start. Make sure you get it set up correctly. That was the hypotenuse. That's always the one alone over there. I know this one, but I don't know that one. I gotta do this too. I'll slow down. So.
I have a quick question. So why on the problem on the left does the 8 squared and the 10 squared, one of them go on the outside of the equal sign, one of them go on the inside of the equal sign? And why on the second problem do they both go on one side of the equation?
All right. And it's funny because it's what I keep trying to say, and obviously the way I
It doesn't matter, right?
that is not clicking, right? This part of the formula, right, is always the hypotenuse number. And the two sides that make the right angle, we call the legs, are the two together on the, whatever you call it.
So if we're looking at the problem in MOM, it will say that this is the hypotenuse corner for us to use?
No, it won't. It won't.
So how do we know?
It's the diagonal. It's the hypotenuse is the one that's across from the right angle, or it's always the diagonal.
Okay, thank you. I never knew this. I don't know if you've mentioned it or I just didn't pick up on it. I don't know.
Oh, I tried to make a big point about it yesterday, and of course, but I know that the first time you hear something, it doesn't click, or there's nothing to hang?
Because I got what diagonal was, but I didn't get what hypotenuse was. I didn't get that they were the same thing.
Yeah, the hypotenuse is the diagonal, and sometimes, you know, it's just, well, I could have a really funny looking, skinny triangle like that, right? As long as you know that's the right angle, that means this one over here must be the hypotenuse, the diagonal one, right? So that's exactly why those numbers, I did these two different versions so that.
So will you only find the hypotenuse on a right-angled triangle?
That term only applies to a right triangle, yes. And this theorem only applies to a right angle triangle. It'll, you won't see some other kind of triangle asking you to try to do this. This one, where did I get 15 something or other? 15, oh, I forget, sorry. 225 plus 1296 is 1521. 1521 is the square of what we want. So now we want the square root. This is like do the same thing to both sides, right? If I square root that, I get just a plain x. So if I square root that, what number do you get? And something tells me that's a nice number. 39. You guys get 39? Oh, Ariel must be having trouble getting in and out here. Okay, we answered some good questions about setup and yeah, hey, I see him. Yeah, look at it. Okay, here we go. Keep moving, right? If we run out of time today, I'll maybe post some suggestions on for you to be sure you look at this or that, and you can send me different problems if you have difficulties. Okay. Oh, let's say. This is one of the what I call the three basic types. Change to decimal. Percent to decimal, decimal to percent. $2.40.
Can you do kind of like a tricky word problem?
Yeah, that's the next one.
Oh, sorry. Thank you.
You ready?
Yeah.
Okay, here we go. Great minds, right? Here we go. Here we go. Tricky. Well, we bought a dress for $70, which was 75% off the original price. What was the original price? This is one of those two-steppers. All right. You need to figure out one thing first and then use it with what else you know. Here's where I say, what percent did you pay? What percent did Amy pay then? If it was 75% off, the percentage left that she paid was 25. So This is like a percent increase or a percent decrease. This is percent decrease kind of problem. Or she paid 100 minus 75. She paid 25%. So now you kind of ignore the 75 and now you can go back and try to write that sentence like the one we just did. $70 was 25% of the original price. 70 is 25% of what? Man, you can probably do that in your head because you understand 25% is a quarter, but got to show me all your work on your scratch paper, okay? Now, I kind of did that.
Okay, in simpler words, can you just explain to me the steps, just how you got the 70 is 25% of what? I understand that that is the answer. It's just hard for me to look at this word problem and come up with that.
All right. So when you read a problem like this, what you kind of want to recognize is this number that's given is off of the original or more than the original. This percentage is an amount less than. So, oh, I got to do a two-step thing. If this is 75% off the original price, oh, that means this number isn't the 75% of the original price. This is what was left. I don't know if I'm making that easier or not.
So that makes sense. So the $70 is the 25% that she ended up paying.
Right, so the 70 that is the left. Right, maybe that's what you just said. 70 is the 25% that's left. So the 70 is only 25% of this original price that we're looking for.
That makes sense. Thank you.
Sure. Just call me up tomorrow. Oh. And that's really a quarter, right? So we're going to get $280. The original price was $280, 4 times that. Your calculator should tell you that. Whoops. One more, okay, of these percentages. You ready?
Thank you.
This is similar, but this time we're looking for the percent number, and we know the original and final numbers, but still it's one of those two-steppers. So here's where I say, well, find the amount of change first. What's the amount of difference, amount of change? And that's the number you want to use. Kind of like the 25% in the last problem was what we were really interested in using. Here, I don't really want to use those two numbers together. Just how much different is it? Oh, okay, the amount of change is that 20. And now I can say, now I want to compare that number to the original. Always the original. What percent of the original is that 20? Which one's the original? The 160. You know, what percent of 160 is that 20? So there's kind of your two steps. Find the difference. Whether it went up or went down, it doesn't matter. You just want to find the number difference. Subtract the little one from the big one. And, you know, then you can say, oh, the percent was an increase or the percent was a decrease if the problem needs you to clarify. So what percent, there's our unknown, when I'm looking for the percent, this is where I always use a P. What percent of is multiply? Of means multiply. Is. And here, I know this number, we're going to get an exact percentage with a decimal in it. Okay, I'm just warning you. I mean, we won't really need to round it because there's only one decimal place. P is 20 divided by 160, or you could even do this with fractions, right? Divide by 10, cancel 2s. This is 1/8. Your calculator should tell you that decimal, what's the corresponding percent? You gotta always be careful when you're, that's why I like writing the P to make you remind me. I gotta turn that one into a percent. 2 places. So from 160 to 180 was an increase of 12.5%. Percent increase, or I could have said it went down and you'd say percent decrease. Yes?
Never mind. Never mind.
All right. Okay. There you go. I was going to move on. That was enough for percent for a minute. Let's see. What do I have written here? All right. Good luck. I haven't looked at this paper in all term, but something makes me think I used those same numbers before. But there you go. Solve for X, play with the fraction. Wednesday, play with your food. When I asked the question yesterday, nobody said they wanted to get rid of the fractions. So I'm kind of guessing, I kind of like it. I'm glad that we're all just that we seem to be working with the numbers. Add, subtract, multiply, and divide with fractions. It's really what I would prefer that we get better at. So combine the x's, get some common denominator, combine the constants, get some common denominator, fractions equal fractions, and then get rid of the fractions at the end. I'm gonna do a step or two here. I did the constants first, like some of you like to do. That order could be switched as long as the negative sign is on the 5/6. And similarly here, the negative goes with the 1/2. Or it could even have been on opposite sides, and then the signs would have all been opposite. All right. I'm going to call this 2/4 x. You all right with that? And I'm going to call this 2/6. Getting the common denominator, right? 2/2, 2/2. So now I can combine the x's, 3, 4, 5/4. Watch the minus sign, right? -5 plus 2, -3, 6. Reduce that if you want. We don't have to. It'll work out at the end. Don't lose anybody. Got to get rid of this 4/5. Multiply by the reciprocal. Same thing over here. Same number, same reciprocal. 4/5. X. Going to be a negative. Don't lose a negative. That'd be a real shame. Just 1 point probably out of 10. But let's see. I could get 12 over 30, but let's see. I divide by 2, divide by 2. Oh, divide by 3. 2/5. Reduced answer. Did you get down to 2/5 all the way? Double check. Make sure I didn't mess something up.
So I have a question.
Yep.
How come I thought you would have to change all of them to the same denominator just to begin with?
Well, it is not wrong to do that, but by the time I got to this step here, where I had all the x's on one side and all the constants on the other side, I could still get all the same denominator now if I really wanted to, but I just need to combine those two numbers on this side to get all the x's together. So I only need to use those two to get that common denominator for this side. And I only need to combine those two on this side.
So in these types of problems, I can add and subtract fractions without common denominators.
Say that again.
So in these types of problems, I can add and subtract fractions without common denominators.
Oh, no, I didn't rewrite the entire step. This is where I was, maybe you were busy writing, where I said 1/2 is the same as 2/4. Is that okay?
Yep.
See, so then I have the common denominators.
Okay, yes, that makes sense.
And
Thank you.
1/3 was the same as 2/6.
Okay, yep,
I just didn't write a whole nother line for it.
that's fine. That makes sense. I was
I
writing
do
it. I
that.
didn't catch that. Thank
Every
you.
time I do that, it confuses somebody. Sorry. Okay. All right. So that's how that worked out. All right. So, all right. If I have what classification do I use for each of these three possible answers? If I start with some messy problem and I boiled it down to that, what term do I use to classify this kind of answer, this kind of equation? I need three different possibilities here, right? This is saying the x number that works is a 4. The only condition that works. In the interest of time, I'm not working a whole problem to get down to that point. I'm saying, if you solved your problem and got to something that looks like this, that's the normal, the conditional. If I worked my whole problem and I got down to something like this, maybe I'd go a step further. Is that true? 0 equals 0? Yes. Are there any x's in there? No, it's not dependent on x at all. Any x value would have worked. Do you remember the name for that kind?
Infinite or identity.
Right, identity. How many possible solutions for this kind?
Infinite solutions.
Infinite, yes, good. Any number for x would have worked. Is this one true? No solution, right? Contradiction. What if I get that one? What's that? That was on handed homework number 1, chapter 4, number 1, week 4, part 1. I saw lots of wrong answers for this one. You're not really done, right? Divide by 4. 0 equals x. 0 is a number. 0 is the one number that would work. This is a conditional equation. It's not a contradiction. You know, 0 happens to be the number that, you know, that made the equation true. Just happens to be that weird one in the middle there on the number line. Not trying to trick you, but just pointing that one out because it showed up on that handed homework, and too many of us got confused by that one. Even something like, I saw somebody left it as x equals 4x. Oh, you know, and like, oh, that must be a contradiction. How can 1x equal 4x? It's a 0. If I subtracted the x, I'd get 0 equals 3x, and then I could divide by the 3 and still get a 0. Just kind of like keep going to get all the way you can to the point where you can't do anything else. Then you could classify it. There's one of those on the test. All right, I'm kind of working backwards here. I'm down to, well, we got a couple minutes left. I was going to do a distributing kind of problem, okay? Here's a messy distributing problem. And then we'll probably be out of time, but send me questions later today and I will try to be responsive. Can you do that one? Why do I put that one up there? The minus signs. Distribute the negative signs to both numbers, right? Negative this, negative that. Negative this, negative that. That's why this example is in there. And then it's combining and moving. And this is the spot that I always, you know, trips people up, negative, negative. And I got to watch out for the distribute that negative. It's like -1 times that. If there was a 2 there, a 3 there, it'd be -2 times everything. Nothing happens to that 20. It's just out there by itself for now. All right, there's my distributing. Double check yours. Combine your x's and your constants. Do that all on one side first, right? Let's see. Put all these x's together. Looks like I have 6 x's and a 12. Put all my, well, okay, 22 minus 4x. Real tricky answer here, right? How about if I add some of these? Run out of time, don't worry about it. I guess classroom I used to say, go ahead and take a picture of that. Go home and study. Put it in your notes. Watch the video again later. I again, just strongly encourage you, of course, make sure you kind of understand as much as we did today of the 3.4, right? Maybe some rectangle problems or the triangle problems, right? And, but otherwise, you know, working through the review, the mom review for chapters 2 and 3, going to give you good sample problems. And I tried to do a little of everything you should expect tomorrow. Okay? And send me some questions and I'll get back to you later this afternoon if you need some help. And if that's good enough, we've got to call it for today. And I'll see you all on Monday, but yeah, it should be Friday. I should have you'll have your test grades posted. Okay? Okay, folks, if that's enough then.
Thank you.
All right, we'll see you later. See you.
Bye.
Bye. Bye.